Hello everyone, welcome to Ieee Expert. Today we are going to see one of the very interesting project which is titled as Alzheimer disease prediction using EEG signals. Usually for detecting Alzheimer disease, everyone going with the MRI image based analysis only. But if you are going with the MRI image based analysis, there is a accuracy related issues will be there. Why MRI images not suitable for the Alzheimer disease prediction means Alzheimer disease directly relevant to the neurological system. By obtaining this neurological feature from the MRI image, which is very low, that's why we are going with the EEG signal. EEG signal directly combined with the neurological system. But by using this EEG signal, we can able to predict the Alzheimer disease very effectively. Also in this project, we can able to predict your depression system also. How much depression you are having. That also this project will predict. This project combines the complete machine learning with the deep learning. This project produces accuracy of 98%. For this project, we have built a complete web application using the machine learning and deep learning. With this web application, you can access end-to-end. This is very useful for all the medical related research students. So watch the complete video. We do provide complete end-to-end details about how we can build the project, how we can implement the project, what are the data set used, what are the methodology we are using. All the details explained on this video. So first of all, we have to go to the project folder. So this is our project folder. Inside the project folder, you can find the code section as well as the documentation section. First of all, I can explain the project PPT as well as the project base paper. Those are the things very important to explain our project. So I can explain the project base paper first. So let me explain the base paper. So this is the project base paper. This base paper IEEE transaction, okay, which is published on 2025, which is very recent year. This is our base complete PPT. I can explain this also. So first of all, I can give you the overview about the base paper. This base paper titled as Graph Signal Entropy for Analyzing Unfunctional Brain Abnormalities of Alzheimer Disease Patient. So this what they have did. So basically what they are doing means they are taking MRI images as an input. So you can see Alzheimer disease is a completely neurological based disease. So which is very much depends upon the brain pattern. So what they are doing means they are taking MRI images. So this is the MRI images. From the MRI images, they are going to extract various features. First band, second band, third band, fourth band. Like that, they are extracting multiple features. Finally, they are combining all the MRI features into the entropy. This entropy going to use this graph signal entropy algorithm. This algorithm will predict this patient having Alzheimer disease or not. That's what they are doing. But the major drawback present in the base paper was, which is very important, analyzing this feature from the MRI images, which will lead to many losses. You can't get all the information from the image itself. This image prone to multiple noises. Okay, you are not taking any random photos from the outside face and all. You are taking the MRI images. Okay, the brain images. Usually, it will produce huge noises. Okay, machine will produce noises. Also this images don't be can't be very clear. Okay, it doesn't have many features. Okay, it's not a feature rich image. It's a very low quality images. So if someone going to predict Alzheimer disease using this low quality images, it will produce the irrelevant accuracy. The accuracy of this project is a very question mark. We have to provide the alternative for this. So we are not going to use this images. We are going to use EEG signal, which is very interesting topic. So this is our proposed system. I can explain the complete proposed system for you. Okay, so this is the proposed system. NeuroDetect. This project uses the EEG analysis of the particular patient to detect the Alzheimer as well as depression. We are not going to do the Alzheimer disease. We are going to additionally apply depression detection with this project. So this is the more innovative project. So additionally, we are using depression also. The project called as NeuroDetect, AI-powered EEG analysis for elderly detection of Alzheimer as well as depression detection. So this is our project concept. In abstract, I mentioned that we are going to present a very intelligent EEG based diagnostic supportive system, which is particularly designed to identify the early neurodegenerative pattern. So what is the meaning of earlier neurodegenerative pattern means? You are going to predict the Alzheimer disease in a starting stage itself. You are not going to predict the Alzheimer disease in a final stage. It will predict the Alzheimer disease in a starting stage itself. Why? Because you are going to use EEG signal here. Also, this Alzheimer disease directly related to the mood related cognitive decline. So we are going to find out the depression detection also with this project. Okay, we are going to use multiple features with that project. What's the meaning of features? Means from the EEG signal we are going to extract particular patterns. This patterns called as a feature. By combining all these features only, we are going to find out this patient having Alzheimer disease or not. This Alzheimer disease not only relevant to the aged patient, even the kids also having Alzheimer disease nowadays. So this is a very important project for current society standard. This project will bridge the gap between the neuropsychological data as well as the ML. We are going to combine all together to predict the Alzheimer disease. Let me explain why this project is a very important. Usually, if you're going for the MRI as well as the PET-based scans these scans are very costly. These scans are very costly. You have to take MRI as well as PET scan for the particular patient. You know about while you are taking MRI scan, you can't wear any metal related content. Even you have to remove your mangalium. Even you have to remove your ring, watches, and everything. That means you come to know that how effective this MRI signals are. This MRI signal will cause many problem for the human. Okay, while taking MRI scan, no person was in the lab, so this MRI was very costly, invasive. It will be very effective for the human body. So that's why we are going for the EEG based signal approaches. These EEG signals are very easy to take, doesn't take high cost at all. Even basic physician will take, doctors will take EEG signal. No need to study MRI screening, MRI imaging and all. Basic doctor itself can take this EEG signal. So this is a very effective project. I can explain one more thing. Neurological disorders such as Alzheimer disease and depression, these are very important for current standard. So we have to predict this diseases as earlier as possible to omit this disease from the human body. That's why this project plays an important role here. Okay, project features. This project packed with the many features. The first feature is automated EEG upload and validation. Basically, these EEG signals are in a MAT file or .eeg format. You can't view the EEG signal with a laptop. So we are going to use EEG upload and validation. If you are uploading the .eeg file or .mat file, automatically it will plot the EEG signals. Okay, automatically this project will plot the EEG signal 1, 2, 3, 4, multiple signal. So this is a very innovative way. As well as this project using the Alzheimer classifier using Centroid-based ML. This project uses Centroid-based ML as a proposed algorithm. As well as this project contains depression risk prediction. With this project, you can upload your EEG signal. It will give you how much percentage of depression you are having. That also the complete innovative model we have added with this project. Okay, as well as interactive dashboard, as well as PDF report generation. With the doctor module, you can enter the patient name. It will give the complete PDF report. This patient having this much of Alzheimer disease, what are the protocol he have to follow? This patient having this much of depression, what are the protocol you have to follow? It will give the complete dashboard as well as a PDF report within a second. These are the features packed with this project. Okay, so exiting system. Usually, these current systems are basically relies on the MRI based images. Okay, these MRI based images will produce a low quality result. I can explain the disadvantages. Okay, it will produce a late detection. Okay, you can't detect the Alzheimer disease as early as possible. It completely depends upon the neurologist. Okay, without neurologist, we can't do this project. These are the basic disadvantages of the project. Okay, automated insight extraction from the EEG. Usually, if you are uploading the MRI images, it can't extract the automated features. You have to select what type of features you need to be extracted. You have to mention all this together. Okay, so this is the complete drawback of the existing base paper, as well as non-standard reporting causing inconsistencies. So usually, if you are uploading the MRI based images, as I mentioned earlier, it produces low accuracy, which means it's not a standard reporting system. You can't use always, you can't rely on the MRI based signals. We have to go through the complete innovative approach. That's what we did. So this is the comparison between the existing system, which is base paper, as well as the proposed system. Usually this MRI based system producing accuracy related to the 85%. But our proposed system, this NeuroDetect, it will produce accuracy of 97%. As well as the exiting system, if you are uploading the MRI based approaches, it will extract MSI. That means MSI, which means mean square error. It having higher error ratio, But our proposed system directly relevant to the alpha power coherence asymmetry. These are the important feature which you are going to do. This feature will produce a higher accuracy, which means 97%. As well as the prediction approach, the existing system is a manual diagnosis. You have to visit the doctor, you have to give the MRI image. They will upload the MRI image and give the diagnosis report at all. But this project, the proposed system is a hybrid computational model. What's the meaning of hybrid computational model? Means we are going to do depression detection as well as Alzheimer detection. Both come together. So this is a hybrid computational approach. As well as in existing system, it's an invasive. You have to go through the lab, you have to lie on the system, you have to take MRI signals and all. So it will produce the higher radiation to your body. But our proposed system is a automated signal processing, which means it won't produce any radiation for you. It's completely safe for your body. And one more thing, user interaction. The complete base paper was some complete research based approach. There is no user interface, there is no user related website at all. But proposed system is a complete user friendly one. Directly you can log in, you can register, you can upload the MRI EEG image, you can upload the EEG signal, you can download the report as a PDF file, whatever. Okay, it's a complete end-to-end application. Also, scope of detection. The existing system is the single focused one. The proposed system is a multi-focused one. As I mentioned earlier, there is two classification for depression detection as well as Alzheimer detection. So this is the comparison between the existing and proposed system, which is very easy to remember. Note all the point together. Okay, and proposed system. Let me explain the complete proposed system. So this is the proposed system which we are going to discuss today, Alzheimer disease detection. So usually this Alzheimer disease is completely relevant to the neurological signal of the particular patient. Everyone taking MRI images only currently. These MRI signals are currently prone to this MMSE, that means mean square error. This mean square error in the image directly affect the accuracy of the system. We have to provide alternative for this Alzheimer detection. That's what we did. We have provided the automated solution, which is non-invasive screening tool, completely uses just EEG signal, the brainwave of the person. By using this brainwave itself, it will extract multiple features. You can see here alpha, beta, theta, delta, and then we are going to extract O2, O1. These are the features I'm going to extract. With these features only, I'm going to find out the MRI disease. That's what I did. Okay, so this is our proposed system. Usually the proposed system, what I'm going to do means I'm going to extract multiple features O1, O2, O1FZ, O2FZ, alpha, beta. So these are the four key features I'm going to extract. With this feature, I'm going to train the machine learning algorithm using centroid classification. You can see centroid voting classification. This is the proposed algorithm I'm going to use. With this algorithm, I'm going to achieve 97% accuracy. This classifier will train the pre-trained file. With the help of this pre-trained file only, I'm going to predict the Alzheimer diseases. Okay. So abnormality. Usually this system won't give the result like Alzheimer present, Alzheimer not present. It won't give the result like that. It will give the percentage. This EEG signal having 75% of Alzheimer disease sign. This EEG signal having 90% of Alzheimer disease sign. Like that, it will give at a percentage, which is very much easier for the understanding. It won't give the result like Alzheimer present, Alzheimer not present. It will give the exact percentage. That's what important of the project. Also, this project will give the same type of result for depression also. This man having 90% of depression, this man having 40% of depression. Like that, it will give the result in a percentage, which is very much important to note down the point. Okay. Also, this is the architecture of the project. As you know, in the web UI, just log in, register, just upload the EEG signal. It will extract alpha power, theta power, coherence power. Then it will give the result as Alzheimer as well as the depression. Finally, you can upload, download all the things, whatever you need. So this is the pictorial diagram for more understanding. You can see here feature extraction is present there as well as the PDF report, Alzheimer detects, and then depression detection. Both the models are present here. Okay. For the database purpose, we are using SQL here. So why not? So these are the models of the project. This project involved 8 different modules: data acquisition module, signal processing module, spectral feature extraction module, connectivity analysis module, Alzheimer classification module, depression risk assessment module, web interface, then automated reporter. These are the modules involved. Basically, this data acquisition module will collect the EEG signals and store on in the database. Then signal process model, what it will do means it will fetch the EEG signal. It will plot as a graph. Spectral feature extraction model, what it will do means it will apply the Fourier transform over here. It will give the important point of the feature. Connectivity analysis model, what it will do means it will extract the four important model alpha, beta, O1, O2. These important feature will be extracted. Then going for the fifth model, so what I'm going to do, Alzheimer classification engine. It will classify the Alzheimer disease, how much percent of Alzheimer that patient having. Then the depression assessment model, what it will do means it will calculate the percentage of depression this person having, how much percent of depression, using those features extracted by the feature extraction model. Finally, web interface model. Okay, we are going to design this project as completely web application. Just do whatever you need, login, registration, upload, download, you can do all the things. Final reporting model, just once the results are predicted, you can download as a complete report with your name. So that's what we are doing in the eighth model. Okay, so sequence diagram, we are giving multiple diagram for this project for your clear understanding about the project. As you see, sequence diagram given here, activity diagram given here, class diagram given here. Why not the UML diagram also given here for this project? So this is the advantage of the project. To implement this project, what we are going to do means, so we have to list the major advantage of this work. Low cost. Basically, this project is a low cost work, doesn't cost too much to implement this. Also, this project work with the EEG signal itself. You don't need high-end MRI as well as PET images, which is this project produces a higher accuracy when compared to all the existing system. Why? Because with this project you can find out the Alzheimer disease in the earlier stage itself. Note this important point. Okay, so hardware and software requirements. To implement this project, we need a Windows based system. Basically 4 GB RAM is enough to run this project. We are going to use Python, HTML, CSS, JavaScript as a language part for this project. For website framework, we are going to use Flask. So conclusion, basically this NeuroDetect is a successful project which will extract the EEG signal. Based on this EEG feature itself, it will predict Alzheimer disease as well as depression, both together. Okay, this project will overcome all the existing MRI-based Alzheimer disease detections. It will give the new path for the innovative medical research. That's what we are going to do. These are the reference for this project. Okay, so connect with this video. I'm going to run the complete demo for you with the coding. Okay, thank you. Now what I'm going to do means I'm going to explain the project code for you. So this is the project folder, full code. So I can open in the VS Code as well as. So this is our training code. You can find those. This is the complete training code we are going to use for this project. So this project uses important data set which is called as open neuro data set. Okay, this is largely accepted medical data set. This data set contains, particularly we are going to use EEG based signals. So this is the data set, EEG data for exploration of Alzheimer disease. You can find the overall data set here. So this project uses multiple subjects, subject 1, subject 2, subject 3, like that. Multiple subjects are there. So you can find the EEG signals here. So this is the EEG signal. Basically these EEG signals are .eeg files. You can find the .eeg files. It doesn't have any graphs at all. We are going to access this file. We are going to plot the EEG signal as a graph from this file. That's what we are going to do. This is a very advanced work. You can find the training code over here. We have did all the work for this project. Okay, complete training code is given here. So this is the app.py. This is our main code to run this project. Okay, I'm going to use this classify here. Okay, complete classifier is here. Okay, we are using some testing sample. Front end part is given here. Okay, login page, registration page, index page, EEG file, depression page, as well as Alzheimer page. Everything given here. So there's a dataset folder also. So what I'm going to do, I'm going to run the project. To run the project, I'm going to open the Anaconda Navigator terminal. So once you open the terminal, I'm going to copy the project folder path. So this is the path I'm going to copy. Once I copied it, what I'm going to do, I'm going to use cd space paste to the project location. That's it. After that, enter. Type python space app.py. Once done, just enter. Python space app.py, just enter. That's it. So now the project is executed. So this is the project address. Just click this link. It will open on a browser. So this is our project homepage. Earlier detection of Alzheimer disease. This is our complete website. Okay, so we have formed using this code set app.py. Okay, so what I'm going to do, this is our homepage. So here you can find why this project is very important. What are the important features of this project? EEG signal plotting, innovative feature extraction, accurate classification as well as depression analysis. These are the important features of the project. What are the tools we are going to use for this project? Everything mentioned here. Then what I'm going to do, I'm going to register first of all. To register, I'm going to use particular details at all. So initially I'm going to use Raman. I'm going to use, not Raman, I'm going to use any different name, Balaji. So Balaji, mail ID balaji@gmail.com. Balaji@gmail.com. Password I'm going to use 123. So mobile number I'm going to give 9988771122. So this is my mobile number I'm giving me. Example only. So address I'm going to use Chennai. So this is the address I'm going to use, Chennai. Okay. So once done Chennai, I'm going to register. Just click register. So once registered means now I can log in. So username Balaji I given, Balaji. So password I have given 123. That's it. Give login. So now the project homepage is come. So here I'm going to upload EEG signal. So I have kept some test signal in a test sample here. So you can find it here also. So test signal. So these are the test sample. Some test results I have stored here. These signals are obtained from this data set. You can see subject I closed like that. You can download. Okay, completely you can download this free only, no cost at all. Directly you can download from the Kaggle website. Now I'm going to upload this test signals. Just choose file, go to the project location. So project Python script, Alzheimer disease EEG, then full code, go to the test sample. You can upload any sample. For example, I'm going to upload this 001 sample. Just choose this one. This is a EEG file. It doesn't have any graphs. Now see what I'm going to do. Just click upload file. Once I click the upload file, what it will do means it will plot as a graph. You can see. So the signal have been plotted. So this is the signal plotting. These EEG signals got plotted. Okay, completely from that file only. Now you can do the feature extraction, Alzheimer analysis and depression analysis. You can do whatever. So for example, I'm going to upload one more signal for your example. This time I'm going to upload this 011. Just see the signal, previous signal. Now I'm going to upload this data set. For the data set, it will plot the different graph. You can see different graph here. So see the differentiation. No, it's a very real-time project. That's what I come to mean that. Okay. So this is the signal, but you don't have any features at all. So first of all, you have to extract the features. So what I'm going to do, I'm going to click extract features. Once I clicked that, my project will extract the features from that. You can see alpha power, O1, O2, O1FZ, O2 FZ. So these are the features extracted from this signal. For each signal, these features will be varied. Okay. So from this signal, we have extracted the features. Now you do have two options. You can find out the Alzheimer analysis. You can find the depression analysis. You can use two options. What I'm going to do, I'm going to run Alzheimer analysis. So once I click it, means it will produce the result. So the result I have been produced. So you can see abnormality detected. 85% of Alzheimer confidence have been detected using Centroid classifier. So the signal which you have uploaded contains 85% of Alzheimer disease. So you can see normal probability 15, Alzheimer disease probability 85%. So these are the result we have extracted. Okay, this is the EEG signals we have plotted. You can download the result also. There are some clinical recommendation also there. Consult a neurologist, lifestyle modification, what you have to do, cognitive monitoring, what you have to take the remember everything. Okay, so just you can save the result also. So now I'm going to result name as a Madan. This patient name is Madan. Just click this. So if you're clicking this, download PDF report. So Madan report have been downloaded. Click this, you can see NeuroDetect report. So abnormality detect, patient name Madan. So this is the EEG name. So overall probability 85%, all the features and everything given over here. Now what I'm going to do, I'm going to check for the another person. Just click another EEG, choose file, go to, this time I'm going to select subject 27. So these data are captured from this one, as I mentioned earlier. So just click upload data set. Once I upload it, it will plot the EEG waveform. So this is the EEG waveform. Now what I'm going to do, I'm going to extract the feature. So once feature extraction done, you can see the features here. So these are the extracted features for the subject 27. Just click run Alzheimer analysis. So if you are clicking this, you can see 100% abnormality detected. So this patient having 100% Alzheimer. This means this is the final stage. So these are the features, everything given over here. Okay. So what I'm going to do, I'm going to do depression detection. For this EEG, I'm going to do depression detection. Just click same for the same EEG. Okay, subject 27. I'm going to do depression analysis. Click run depression analysis. Okay, so once I click the depression analysis, you can see this patient having 38% of depression probability. So for this also you can download. For overcoming depression, what we have to do? We have to concentrate on mental routine, as well as we have to maintain the balanced diet and everything. Just click download. Same method I'm giving this time. Just click depression download report. Okay, so this is the depression risk analysis for the mother. Okay, 38%. I'm going to check with the another person also. This time I'm going to choose different person, 16. So I'm going to upload for 16. So this is the 16 EEG. You can see the different EEG waveform of the 16. So I'm going to extract the feature for 16. So once feature extracted means you can see the features. So these are the feature for 16. Just click run Alzheimer disease. Once Alzheimer disease analysis, you can see this person also having 100% Alzheimer. Then I'm going for the depression for this particular person, run depression analysis. So this person having 66% of depression probability. See the indication for the depression pattern. The O1 versus O2 was very high, which means this person having higher percentage of depression. So this is how this project will work. Okay, I can show you one more thing. This is the accuracy part. Click analysis. So the analysis shows the accuracy of the project. This project produces 98% training accuracy and 97% texting accuracy. Error rate was 1.8, which is very lower. So these are the important features we are going to consider. So this is the accuracy graph. Also, I have made the confusion matrix for everything. Okay, so this is the project accuracy result. This is very innovative project. To get the project, click the description. There is a link. Click the link. You can purchase the project with very easy support. Okay, this is a very innovative project. Also on our project list, there are plenty of projects available. You can check all the list of projects available. You can purchase whatever project you wish. Okay, thank you.